Hello class, welcome to Stat 1200. I am your instructor William Buellman, and today we are covering section 7.2, confidence intervals for a population mean, sigma, the population standard deviation, unknown. The objectives for today are to describe the properties of the student's t-distribution and to construct confidence intervals for a population mean when the population standard deviation is unknown. When constructing a confidence interval where we know the population standard deviation, the confidence interval is the sample mean plus or minus the margin of error. The critical value is z alpha by 2 because the quantity right there has a normal distribution. It is rare that we would want to know the value of sigma while needing to estimate the value of mu. In practice, it is more common that sigma is unknown. When we don't know the value of sigma, we may replace it with the sample standard deviation s. However, we cannot use z alpha by 2 as the critical value because that does not have a normal distribution. The normal distribution of this quantity is called the student's t-distribution. There are actually many different students' t-distributions, and they are all distinguished by a quantity called degrees of freedom. When using the student's t-distribution to construct a confidence interval for a population mean, the number of degrees of freedoms is 1 less than the sample size. Students' t-distributions are symmetric and unimodal just like the normal distribution. However, they are more spread out. The reason for this is that S is on average a bit smaller than sigma. Also, S is random whereas sigma is constant. Replacing sigma with S increases the spread. When the number of the degrees of freedom is small, the tendency to be more spread out is more pronounced. When the number of the degrees of freedom is large, the sample standard deviation S tends to be closer to the population standard deviation sigma. So the t-distribution is very close to the normal distribution. So if we look at this graph down here, we see with 1 degree of freedom this brown dashed line. It's not very close to the normal distribution. It's more spread out on the ends and the peak isn't as high. When we get to 10 degrees of freedom, that red one, we're pretty close to the normal distribution. And as we get closer and closer to infinity, larger and larger numbers, we will get closer and closer to that black line, which is the standard normal curve. To find the critical value for a confidence interval, let 1 minus alpha be the confidence level. The critical value is then t alpha by 2 because the area under the student's t-distribution between negative t alpha by 2 and positive t alpha by 2 is 1 minus alpha. So this is very close to the normal that we saw when we had sigma known, but instead of using the z distribution, we're using now the t distribution. So we're not using the normal, which is z's, we're using this t distribution now. The critical value t alpha by 2 can be found in table A3. And the rows correspond to the number of degrees of freedoms and the column corresponding to the desired confidence level. So on the left-hand side, you have your degrees of freedom. That'll be your row. And then depending on what area you want in the right tail, here are the different areas, you will match that up just like you do in the normal table to come up with what the critical value is. Example 1. A simple random sample of size 10 is drawn from a normal population. Find the critical value t alpha by 2 for a 95% confidence interval. The sample size n is 10, so the degrees of freedom is that sample size minus 1, so 10 minus 1, which is 9. So now we consult table A3 looking for 9 degrees of freedom and the area in the right of 0.025 because that is for 95% confidence what the right tail will be. So we find where those two match and we get that the critical value is 2.262. What do we do if the number of degrees of freedom isn't listed in table A3? This is what we can do. The first thing we can do is, if the desired number is less than 200, use the next smaller number. So go down in number that is in the table. If the desired number is greater than 200, we can just use the z-value on the bottom row because it's close enough at that point, or you can use table A2. So in order to do this, we have some assumptions. The assumptions for constructing a confidence interval for mu when sigma is unknown is as follows. Again, we need a simple random sample as before, and we need a large sample, n greater than 30, or the population to be approximately normal. When the sample size is small, less than 30, we must check to determine whether the sample comes from a population that is approximately normal. A simple method is to draw a dot plot or box plot of the sample. If there are no outliers and if the sample is not strongly skewed, then it is reasonable to assume that the population is approximately normal, and it is appropriate to construct a confidence interval using the student's t-distribution. If the assumptions are satisfied, the confidence interval for the population mean when the population standard deviation is unknown is found using the following steps. Compute the sample mean and the sample standard deviation if they are not given. Find the number of degrees of freedom and the critical value. Compute the standard error, multiply it by the critical value to obtain the margin of error. And then we construct a confidence interval by taking the sample mean plus or minus that margin of error. And then finally, you have to interpret what that result means. A food chemist analyzed the calorie content for a popular type of chocolate cookies. The following are the numbers of calories in a sample of 8 cookies. So here are the different 8 cookies and their calorie contents. Find a 98% confidence interval for the mean number of calories in this type of cookie. So first, we have to check the assumptions. We have a simple random sample, check. Because the sample size is small, we don't have n greater than 30, we need a normal population. So now we need to check to see if this population is normal. A dot plot indicates that there's no evidence of skewness. If we look, we don't see it heavily to the right or to the left. And there's no outliers. None of these are very far off from the others. So we can say that the population is most likely normal and proceed. Now we find that the sample mean and the sample standard deviation. We have the sample mean is 115.375 and the sample standard deviation is 2.8253. The number of degrees of freedom is the sample size minus 1, so 8 minus 1, which gives us 7. If we look at table A3, we can find that the critical value for 98% is 2.998. First, we calculate the margin of error, which is the critical value, times the standard error, which gives us 2.998 times 2.8253 over the square root of 8, which gives us 2.9947. So that is our margin of error. So now we have to calculate our confidence interval, which is our sample mean plus or minus our margin of error, which is 115.375 plus or minus 2.9947, which gives us 112.4 is less than mu, which is less than 118.4. So we are 98% confident the mean number of calories per cookie is between 112.4 and 118.4. Example 3. Example of 123 people aged 18 to 22 report the number of hours they spent on the internet in an average week. The sample mean was 8.2 hours with the sample standard deviation of 9.84 hours. Assume this is a simple random sample from the population of people aged 18 to 22 in the U.S. Construct a 95% confidence interval for mu, the population mean number of hours per week spent on the internet by people aged 18 to 22 in the U.S. First, we check our assumptions. We have a simple random sample, check. We have a sample that's larger than 30, 123, so our sample size is large, check. Our assumptions fit. Now we may proceed. Note that the sample mean was 8.20 and the sample standard deviation is 9.84. The number of degrees of freedom is the sample size minus 1, which is 123 minus 1, which is 122. Since this value does not appear on the table, we must use the next smallest value in the table that does appear, which is 100. So we go to 100 and go to 0.025 because that's for 95% confidence, and we get that the critical value is 1.984. And we need to calculate our margin of error, which is our critical value times our standard error, which is 1.948 times 9.84 over the square root of 123, which gives us 1.7603. And now we can calculate our confidence interval, which is our sample mean plus or minus our margin of error. So 8.20 plus or minus 1.7603, which gives us 6.44 is less than mu, which is less than 9.96. So we can say we are 95% confident that the mean number of hours per week spent on the internet by people aged 18 to 22 is between 6.44 and 9.96.